Once again, good evening, everyone. A very warm welcome to all the faculty members, research scholars, and postgraduate scholars for joining the session today. Greetings from Division of Electronics and Communication Engineering, Karunya Institute of Technology and Sciences, Coimbatore. We are truly delighted to have you all with us for the third day of the AICT ATL-sponsored 6-day online FDP program on AI/ML-based reconfigurable antenna design for next generation wireless communication. Today's session will be handled by the technical expert from Tools Technologies. The session will include design and analysis of metamaterial and bandpass filter for the multiband application. Today also the session will be handled by Mr. Dhanush, High Frequency Application Engineer from Tools Technologies Private Limited, Bangalore. Mr. Dhanush, specialization in the ANSYS High Frequency Structure Simulator and has developed strong expertise in tools such as HFSS, Maxwell circuits, multiphysics, and space plane. He holds a bachelor's degree in Electronics and Communication Engineering from MIT Mysore and has 2 years of industry experience in the field of high-frequency simulation. Beyond his technical expertise, Mr. Dhanush has been actively involved in conducting workshops, training programs, and faculty development programs across India. He is an ANSYS certified professional in electronics engineering, and his dedication to advancing high-frequency simulation technologies has made a significant impact in both academia and industry. Thank you, sir. I welcome you for this session and spending your time with us.
Thank you.
Sir, you can handle the session.
Yeah, thank you, ma'am. Thank you for
Thank
the
you.
introduction and thank you for the opportunity. This is my second day, what I'm presenting here. Who all new to ANSYS HFSS? Please raise your hands. Because based on that, I'll be proceed further. What today's agenda I'm planning is I'll be give like basics of ANSYS HFSS, like what we can done before going to a tool. For example, how to assign a boundary conditions. It's a completely a basic level because so many participants are new to ANSYS HFSS, so I'll be going with the basics, very basics. How to assign a port, what are the solution types available. I'll be explaining that, then I'll be go further. What are the steps? First, for today, I'll be designing microstrip patch antenna, then metamaterial. I'm not go deep dive into a theory part, but I'll be showcasing how to design the metamaterial splitting resonator in ANSYS using ANSYS HFSS. Then I'll be showcasing how to design bandpass filter. In tomorrow's sessions, I'll be taking one log periodic antenna. Then I'll be try to make one equivalent circuit using that. I'll be showcasing in the next day session. As today's agenda, I'll be covering the metamaterial microstrip patch. First, I'll be going with the microstrip patch. It will take very less time to design that, and even the metamaterial also. I'll be showcasing the results. What are the results we can expected from those designs. I'm not taking much time to take a designs and all. I'll be presenting my screen now for explaining the basics. What are the like solution types? Why we using that solution type? Solution types in the sense we have like so many solvers in it, right? So based on that, we need to assign boundary conditions or excitation. Like that, we will be assigning using the in ANSYS HFSS. I'll be present my screen now. Like everybody heard about HFSS, right? ANSYS HFSS. You can raise your hands, no issues.
Participants can raise your hand.
Like I'll go with the basics first. Okay. You all new to ANSYS, right? Okay, I'll be start from basic thing. First, I'll be giving a basic introduction of ANSYS HFSS, how it will looks and what are the options available in it. All those things I'll be cover in another 10 minutes. Then I'll be go to a ANSYS HFSS, then we'll be create a project using a dimensions, what we have a dimensions, and I'll be showing antenna toolkits and where we can add the Python code. I'll be showcase everything there. Okay. This is how to create a new project in after opening ANSYS HFSS. You will able to see this new option. Click on this new option before going to a new, able to see this windows like ANSYS HFSS, Q3D extractor, circuit, emit, IcePack, Maxwell, mechanical, all those things you can able to visible there in the modeler. Then just after that, you can click ANSYS HFSS. You able to see this HFSS. You can click HFSS there. Then after that, you can click new project. Then it automatically create a new project. Okay. This is the GUI of ANSYS HFSS. This we call it as a title bar. Below that we call it as a menu bar. This is a modeler. Using this modeler itself, we will be take a rectangular, a spherical, or cylindrical, or all those things we will be taken from this modeler itself. This is a 3D object, and this is completely a 2D object. In this, you can using this HFSS only, you can do a validation check, and you can assign a boundary condition, everything. And coming to a project manager, in this project manager also you can assign a boundary condition and excitations and operating frequency, everything. Then you can visualize your what are the things you can creating a geometry in a workspace. Everything you can visualize using this project manager itself. And this is a history tree, and how many box we created, how many spherical we created, all those things you can click and play. Like just you can click and you can visualize what are the box, where it is located, all those things you can visualize using this history tree. This is we call it as a history tree, and this is a project manager, and entire this thing is a workspace. Here itself you can work here. This is a Cartesian coordinate system we are using for designing this HFSS. We have three types of coordinate system, but in this workspace you can see a Cartesian coordinate system. This is how to create a 2D structure. Coming to a hands-on, I'll be showcasing how to create a 2D structure and a 3D structure. Just click on draw, then you can see this 2D structures, rectangular, circular. These are the 2D structures. Once otherwise we can select from a modeler itself, from here itself. Otherwise you can select from the draw. In a above the modeler you can see the draw, right there you can select this options. Otherwise you can select from this modeler option. Okay, I'll be showcasing how to create this rectangle in a once we enter to the hands-on. Then this is entirely a 3D objects. Here just you can click and place to a workspace, then you can see the 3D structures, entire 3D structures there. Next, you have a very good option in ANSYS HFSS. Who all users of ANSYS HFSS, they can know, they will be know this options. What is hide selected object in active wave, or show selected object in active wave. All those things they can explore these conditions when you are going to very large structures, when you are designing array structures or phase arrays, or you are designing any metamaterial structures. For that time you can use this hide selected objects or a show selected objects. You can visualize all those options to create for better design. Okay, first you can see this show all object in active wave. You can click this, you can see all object active in a workspace. Like for example, you will be creating any sphere, or you will be creating any circle, otherwise you will be creating any 3D substrate. There everything will be visualized after clicking this. Okay, if you want to hide something, like hide in the sense it will be not deleting, just hide entire structure of this box, then you can select this and click on hide, it will be hide. Then you can, if you want to visualize again, then you can click all, like this option, then you can visualize all hide objects. Okay, this option you can select only hide selected object in an active wave. Okay, next this option show selected object in an active wave. Just you can click the circle, then you can visualize that object. Thus you can show only selected object in active wave. You can select one object, then click this option. You can visualize only that option. Other will be hidden. Like other objects will be hidden. Okay, this is what I'll be explaining that. Next, we have select option. There, if you want to do like select entire face and edges or vertex or multiple vertexes. When we use this option, like if you want to assign a boundary condition for all objects, that time you can go with this select object all. Like you can say click this object, entire object will be selected. Okay, when you click face, when you are assigning a unit cell concept, for example, if you want to assign a primary secondary boundary condition, like we call it as a master and slave, right? You need to assign those boundary conditions, then you need to click this face to assign those kind of boundary conditions. If you want to do a chamfer or like you want to do a truncation, that time you can go with this edge and vertex. Okay, then you can do a multiple like chamfer or truncation. That time you can go with this multiple. This is a select object options available in ANSYS HFSS. Next, this is a pan. There you can change that entire position to change the position in an object for a better visualization. That time you can use this pan. Then you have a rotate option to rotate your design, and you want to see the back like bottom of your design. That time you can use this rotate option. Otherwise, we have another option called orient, but there you can click just the bottom. Directly it will come to the bottom. If you want to see visualize all those things like bottom side object, that time you can go with that uh, rotate option. Next, we have a orient option. There you can see a top, bottom. If you want to see the top angle to assign like a port, a fluket port or in lumped port. If you want to assign only for a top object, that time you can go with this orient options to select a top, bottom, right, of like all those six isometric. Then you can go with this like orient option. Next, these are the shortcuts if you want to use to like once you will be more comfortable with ANSYS HFSS, then you can use the shortcuts to fit view or zoom the screen or zoom out the screen or drag or rotate it or zoom in, zoom out. Or like if you want to see the wireframe or that entire smooth shaded models, or if you want to select the faces in the clicks itself, all those things, the shortcuts are available. Using the shortcuts, if you like, if you consume like more time, then it will be reduced to less if you're more comfortable with hands-on. This is unite option. Why we use this unite option means to like make all three different object or different component make as a one. It looks like a one. If you want to create this T object, you need to use a two rectangle. Then you can select those two rectangle and make that unite. But that option you can use this unite option. Next, you have subtract. There, if you want to like remove some unwanted space between, if you want to create U slot or different slot antennas, then you can use this subtract option to subtract, remove that face, remove that like entire space there. Next, coming to a project manager, what are the things you have you able to see in a project manager? Coming to a model, there you can see a geometry structures. There you can create a structure and you can visualize those structures there. Next, coming to a boundary condition, there you can visualize what are the boundary condition you are assigned to.
हाँ अच्छा
Hello.
हम्म
Yes, sir. You can continue.
Yeah. Uh, Next, coming to our boundaries, there you can visualize these boundary conditions. For example, if you want to assign a boundary condition to a ground object, then you can visualize the entire ground there. Then if you want to assign entire like complete box, then you can visualize the box. All those things you can visualize in using this project manager. Then if you want to see the excitation, excite in the sense of the port, then you can click on this excitation where it will be assigned. Next, coming to a hybrid region, if you are doing any complex designs, then you can use this hybrid regions to combine the solvers. For that time, you can use this hybrid regions. Next, coming to mesh operation, there you can use like volume based or surface based mesh options are available. No need to mesh. Actually, it's a default mesh. If you want to mesh your entire objects like complete smooth or finite mesh, that time you can go with this mesh operations based on your own interest. Okay, next coming to analysis, there you can see you can assign operating frequencies, then maximum delta values, where it will be start, like sweeps from where it will be start and where it will be end. All those things will be assigned in analysis part. Next, coming to optometrics, there you can visualize that like optometrics of an antenna length and width optimization and tuning and sensitivity. All those things you can done using this optometrics option. Next, you can able to see the results using click on this result option. There you can visualize this parameter written sorry 3D gain radiation pattern, 2D radiation pattern. All those things you can visualize VSWR. Everything you can visualize using this post-processing result part.
Excuse me, sir.
Yes,
Sir, actually, what is the purpose of perfect key, sir? And where we used PEC and where we use ground, sir? Conductor.
sir.
What is the
Sir,
difference, sir?
repeat your question, sir. Repeat your question. I
So,
didn't
what
get.
is the purpose of perfect key? One thing.
Okay.
Second one is where to use PEC and where to use conductor, sir.
Sir, conductor, like it's a perfect electric conductor, sir. I'll be
Okay.
showcasing once I'll be coming to a hands-on. There I'll be assigned where you need to click for assigning a PEC or where you need to click for a conductor. I'll be showcasing in the upcoming slides. I have hands-on also. There I'll be explaining each and every boundary conditions where you need to click for a PEZ or where you need to click for a conductor, finite conductivity. All those things I'll be explaining in that part, sir. That part.
Okay, sir. Okay.
Just
Thank you, sir.
I'll be briefing out the GUI, sir. That's it. Once I'll coming to a step into a hands-on, there I'll be give a more like information about this PC or lumped port, flipped port, everything. Next, coming to a field overlays, there you can see visualize. You can visualize that like electric distribution inside of structures. For those things, you can use this field overlays. There you can visualize like J vector and H vector, all those things, or E vector. Everything you can visualize using this field overlays there. Okay. Next, coming to a solution types, we have a set of solution type based on your requirement. Coming to HFSS, this is a first step to create a design. First, you need to select the solution type, then only you can go for a design, like creating entire design. First, HFSS. Why we using this HFSS? If you want to design an antenna, filters, waveguides, everything, this is a default solution type. We like answers will be fixed here. Then next, if you want to create an array, that time you can use with HFSS and hybrid and array solvers. There you can create like arrays, and if you want to merge a solvers, that time you can go with this HFSS with hybrid and array. Okay, next, coming to transient solvers. If you want to calculate a problem in a time domain, if you want to design in a transient or a time domain, that time you can use this solution type. Next, coming to a SBR. SBR is nothing but shooting and bouncing ray. That as for like visualize like a far field, or if you want to do to yesterday I'll be day before yesterday I'll be showcasing one network plan. For those kind of simulations, you can use this SVR solvers. Next, coming to eigen mode solvers, if you want results in the form of resonance for a given structures, entire given structures, that time you can go with this eigen mode solvers. Next, we have a characteristics mode. There, if you want to calculate the characteristics of an structure, characteristics mode of a structure, that time you can use this characteristics mode. Next, we have network analysis and composite excitation. Network analysis, it's a default solution type option we are using for normal designs. If you want to do a very large complex designs, that time you can use this composite excitation for making uh, solve a large frequency. That time you can go with this composite excitation. Next, we have very important option to select a model or the terminal. If you select a model, the S parametric solutions will be expressed in the incident and reflected power for transmission and motion. In this model, you can visualize a result as parameter result in a TE and TM mode. Coming to terminal, there you can see the results, all those things. It will be worked on TEM mode. Okay, and the S parametric results will be expressed in the expressed in the terms of voltage and the current. Okay, next, why we use the boundary conditions? What is the purpose of the boundary conditions? It will be defined the behavior of electromagnetic fields, whether it will be at edge or the surfaces, or it will be a computational domain, and it will be ensuring a proper electromagnetic wave interacted within the simulation area. What we giving that for a Cartesian coordinate system, the dimension, the limit is minus infinity to plus infinity, right? For those for that purpose we'll be using this boundary condition to it will be simulated inside that simulation areas. For that purpose we'll be using this boundary conditions. Next, what is the modeling practice we'll be following in ANSYS HFSS? First step is to generate a 3D structures, where for first we need to create a structures. First we need to create a substrate or patch, especially when your final dimensions means, then you can create entire structures there. After this, you assign a boundary condition and the excitation, for a 2D sheets or a 3D sheets. If you assign a boundaries like perfect E, perfect H and radiation, or a primary or secondary boundaries. If you want to assign a finite conductivity boundaries or lumped RLC boundaries, those there you can assign different boundary conditions and different excitations. This is the second step what we followed in ANSYS HFSS. Next, we have a solution type. There you will be assigning uh, operating frequencies and the maximum delta value and the sweep, where it will be start and where it will be end. Uh, those things will be assigning in this solution setup. Next, coming to analyze, there it will be a fourth step, whether we need to check a validation check there. Before everything will be correct, you need to go for analyze all. Then you can face any errors, you need to go back to a entire 3D structures and change the structure. Then you come again to analysis. Then you do analysis part. After that, you can see a post processing. In this post processing part, you can see results like S parameters or radiation pattern. All those things you can see visualize in this post processing part. This is a modeling practice what we followed in ANSYS HFSS. Next, what I explained, how to create a geometry, boundary conditions, and excitation, solution setups, and validation analysis after post processing. Everything will be yesterday. I'll be explained this process in the day before yesterday session. Next, how to create a boundary conditions. If you want to assign a boundary conditions, means if you click the object, right click on the object and assign boundary, click assign boundary, next click the perfect. We have so many options in it, like coupled boundary. In this coupled, you can see if you want to create any unit cell concept, that time you can use this coupled boundary. Next, Febby boundaries. If you are doing any Febby, using this Febby boundaries analysis, if you want to do a hybrid analysis, that time you can go with this Febby boundary. Next, if you want to more conductivity, for that time you can go with this conductivity boundaries. Next, you want to do a impedance, then you can go for impedance boundaries. Next, coming to layer impedance or linked impedance. Then if you're coming to lumped RLC, if you want to assign a lumped RLC, means if you want create a structure, then if you want to give a values for those resistors or capacitors, that time you can use this lumped RLC boundaries. Next, perfectly, if you want the entire structure should be perfect electrically conducted, that time you can use this perfect E boundary condition. If you want magnetic, then you can go with a perfect H. Then if you want to go for a radiation, entire outer boundary, then that time you can use this radiation boundary. Next, if you want to do a PML boundaries, that option also available, then click on and you can go further with that PML setup wizards there. These are the boundary conditions available for your designs. Next, coming to excitations, we have how to create an excitation means. For example, if you want to give current for this port, then you can select this phase and right click there and assign excitation. Then you can click port, then you can see the circuit port, fluted port, a lumped port, and a wave port. If you are designing any band pass filters kind of things, you can go with a wave port. Who are doing a lumped port like analysis, if you go with a lumped port. If you are going with any unit cell concept, that time you can go with a fluted port. If you are using any circuits like lumped RLCs, there you can go with a circuit port. These are the excitations available in ANSYS HFSS. Next, this is a like window appears once we'll click on this analysis. There you can add the advanced means if you want to assign operating frequencies and number of passes, in the sense number of iteration, how many iterations you want to do in ANSYS HFSS to get an accurate results. That time you can use this number of passes. Next, maximum delta of passes, it's a scale value, how many scale value if you want to do assign that there. Next, if you want to do a dual band analysis or broadband analysis, that time you can use this multi frequencies and the broadband option. Then you can assign your frequencies there. Next, click on this auto. You're able to see this sweep option. We have three types of sweeps. I'll be explaining in a further slides. In once I'll be stepping to hands-on, there I'll be explaining fast and including in or discrete sweeps. We have three types of sweep type: discrete, interpolating, and fast. There you can assign a start and stop frequency. It's a scale values. There you can assign a start and stop frequency. Next, coming to analysis, there you can see this analysis part. Like coming to a validation check, there is any errors is there, it will be like it will be showing in that validation part itself. Then if there is no error, you can go with analysis on. And these are the post-processing 2D S parameter results. I'll be showcasing how to get these results in a hands-on session. These are the results we can expect from ANSYS HFSS. These are the major results what we are looking into. Next, we have a gain plot. This is a radiation pattern. And next, we have a magnetic key fields. I'll be showcasing how to animate this in a hands-on session. This is a entire animated like, magnetic key field animated structure. And if you want to check the Smith chart, then you can use the Smith chart tool, and you can visualize the Smith chart, and you can do a like impedance matching using the Smith tool. Thank you. I'll be coming to hands-on now. Any doubts, you can like, interrupt me and ask me your doubts.
Sir, you mentioned that.
Sir, your voice is breaking, sir.
Sir, can you explain all the things?
Yes, yes.
No, sir. I will ask that, sir.
Yes. Okay, sir. Okay. This is what I explained in entire GUI. This is a project manager, and this is a history tree, and like this is a modeler, this is a title bar, and we have some components here. There you can see you can do a EMC analysis. There we have set up standards there, and next we have like or if you want to do a SAR analysis, then you can go with the human phantoms there. Like we have some like RF simulation part, like if you want to take a SMA connectors or female SMA connectors as male SMA connector, that time you can go with this RF component, and we have some inbuilt circuits in it. All those things available in this part. Okay, if you want to do an ADAS, that time you want to see the like vehicles, what are the vehicles available in it, and all those things you can visualize. You can take an entire model and you can do a simulation there. Okay, I'll be start creating with microstrip patch antenna. First, I'll be given applications. What are the applications we can done and using microstrip patch? We can use pages and cell phones, like where we can use the microstrip means you can use in a pages in the cell phones. Then you can use for Doppler and other radar such as like RCS simulations, you can use microchip patch. Or if you want to do a satellite communication, that time you can use this microchip patch. And for a radio communications also you can use this. Or if you want to do for a telemetries in a missiles, that time you can use this microchip patch. Next, if you want to do a biomedical radiations, for example, if you want to do SR rating analysis for your phone, for those kind of, for if you want to do MRIs or cancer detections, all those things you can use this microchip patch there. Next, like some advantages of a microchip patch means, like that, and like microchip patch is like very lightweight and the low profile and the low volume. And coming to fabrication, it's look low fabrication cost and easy for the mass production. Why? Because we're using the FR4. It's easily FR4 dielectric material is easily available in the market. For that purpose, you can do like fabrication cost is very less, and it's very easy for a mass production. Why? Because like only a single structure. For that purpose, it's very easy for a mass productions there. Next, coming to a linear and circular polarization is possible there in using microchip patch. And dual band antenna can easily realized. For that purpose also you can use this microchip patch. And coming to feed lines and matching network can easily integrated with antenna structures. Okay, that's the advantages, slight advantages of microchip patch. Next, we have some disadvantages. I didn't much focused on the disadvantages, just I'll be focused only on advantages. And coming to disadvantages, I'll be giving some two or three disadvantages. It's like completely a narrow bandwidth, and the microstrip patch have disadvantages in power handling. It's a low power handling capacity it have. And it have a poor isolation between a feed and radiating elements. That's how they increase the isolation. That for that purpose, we have some disadvantages in the microstrip patch. But we have some more advantages. And we already create, like we have already calculate the dimensions for microstrip patch using like design parameters like effective dielectric constant formulas. And we are using patch and width formulas to calculate this dimensions. We already calculate, using that only we will be creating a structure. Next, we are using dielectric constant. We are using FR4 epoxy, and that dielectric constant is 4.4, and the loss tangent is 0.02, and cost us comparatively other dielectric materials. It's comparatively 30 to 40% less compared to other dielectric constant materials. Next, I'll be showing step by step how to create a microstrip patch. If you want, you can take a pen and note it down what are the steps and what are the dimensions I'll be showing. If you have any doubts in between, you can interrupt me and ask your doubts. What are doubts you have? Okay, first I need to create a 3D structures. Then only I'll showcase in the model practice, right? First I'll be create a geometry, 3D geometry. Then I'll be assigning boundary excitation. Then I'll be go for analysis. Then after go for a validation. Next go for a post processing. I'll be go with the step-by-step process. If you want any like dimensions, you can damn me. You can ask your questions. I'll be give a dimensions as well. First, for creating a microstrip patch, I need to use a dielectric material. Using that, we will be create a substrate. This is this is a 3D structure, and this is a 2D structure. The substrate, I need to create a substrate. Substrate is 3D. Before going to that, first step we need to do means we need to assign a solution type. Click on this HFSS on a title bar, solution type. Then you need to select a solution type as HFSS. Then network option as network analysis, and the option is model. Then click OK. What this auto open region means, if you want to create automatic open region, like outer boundary, if you want to create automatically, then you can click on this auto open region. It automatically create outer region. If you want, otherwise you can create a manual. manually outer region. Just I click OK here. Then next step is I need to select units. Coming to this modeler, in the title bar, you need to click modeler to change the units. I'll be selecting units option. We have so many units. We have miles or kilometers or centimeters, nanometers, everything will be available. I'll be doing this project in a millimeter, so I'll be selecting in one. Okay, next I'll be click OK. Now the entire structure will be designing using this only. First, I'll be creating a substrate. For that, I'll be take this box. This is a 3D box. Remember, for 3D, 3 clicks. For 2D, 2 clicks. First, if you select this box somewhere on the workspace, why? Because you know the dimensions, right? You know the dimensions. So somewhere on the workspace, you can create your box. Click one and drag this. Click one more time. There's a second click and take up or take down. Then click 3. It will be create a 3D box. Okay, now the box will be created. For this, you want to change the name or the material or a dimensions, that time you can double click on this box, you can change the name and you can change the material. If you want to double click on the box, if you want to change the dimensions, that time you can double click on this create box. First, I'll be changing the name of this box and the material of this box. Then I'll be double click on this box one. Now you can change the name. I'll be changed to substrate. Next, I'll be change this material. Select this material, edit. I'll be selecting FR4. I'll be searching here, FR4. I'll be select this FR4 material. Click OK. Now the FR4 material will be assigned. Next, if you want to change this color or transparency based on your requirement, you can change this color and the transparency. This transparency, for better visualization, you can change this transparency also. Okay, just click OK and apply and OK. Now the name and the material and the color, if you want to change the color, you can change your color, and the transparency also changed like this. Now I'll be double click this box. Okay, in this position, I'll be assigning the coordination, like coordinate system position, then X size and the Y size and the Z size. Now the position of an substrate, I'll be assigning -25, -25, comma -25. This is the position of the XYZ coordinate system, and X size is 50 mm, Y size is 50 mm, and Z size is -1.6. Z is nothing but height of the substrate. Then I'll click apply. Okay. Now it will be okay. Now that entire substrate will be created. Now I need to create a patch. Okay. Now I need to create a patch. For that, I'll be using 2D rectangle. This is a 2D rectangle. I'll just click on this. Draw somewhere, like draw where you want. You can draw somewhere. Why? Because we have a dimensions. So for this 2D object, you need to click 2 times. Click 1 and drag like this and click 2. Now the rectangle will be created. Okay, you need to rename this rectangle. For that, I'll be double click on this rectangle. I'll be renaming this as a patch. Okay, if you want to change the color, you can change the color based on your requirement. Then transparency based on your requirement. Click OK. Always use light colors when you are going with a large structures. Okay, now I'll be assigning dimensions, means you need to double click on this create rectangle, then enter the position. We already have some positions. I'll be entering that minus 14 comma minus 14 comma 0. And here this is 2D, right? We have only x and y. So x size is 28, y size is 28. Somewhere we missed here. I'll be pasting it. Oh, sorry. You know, now it will become to a position. Just I'll be clicking Control D to fit all. Next, I'll be, if you want to see a top view of that, then I'll be select this orient, click on the top view. Now you can see the top view, right? Next, if you want to see the bottom, then you can select bottom. Want to see right, then based on your requirement, you can click assign it. If you want a normal face, just click on this orient. Now it will be coming to a normal again. Next, I'll be creating a ground plane. Next, I'll be creating a ground plane. For this, I'll be taking a triangle. I'll be taking triangle. Sorry, rectangle. Then I'll be draw from exact where the substrate starts. Just click on here, then end where it will be. Now the ground creation is done. If you have a dimensions means, you can click on this create rectangle. The dimensions are correct, minus 25 comma minus 25 comma minus 0, and x size is 50, y size is 50.
Sir, we are unable to see the values what you are entering, sir. All the structure is visible, but whatever the create rectangle, after pressing create rectangle, a window will be open, no, sir.
Sir. Sir.
We are unable to see that window, sir. Whatever the values you are supposed to enter.
Okay. I'll be stop and I'll be again presenting. Sir, now you're able to see the window of the dimensions.
Yes, sir. Yes, sir. Thank you, sir. Thank you.
Yeah, thank you. Thank you for letting me know. Okay, now I'll be created this ground plane. Select this rectangle one. I'll be rename this as a ground. If you want to change the color based on your requirement, you can change the ground color. And if you want to increase the transparency, you can click on this transparency. Click OK. Click apply. Okay. Now it will be renamed as a ground. You can see this object. This is the entire ground and this is patch. Okay. Now I need to create a transmission line. First, I'll be create one quarter wave. That is line I'll be creating. I'll be using this rectangle. I'll be create somewhere on the workspace. Just I'll be create like this somewhere on the workspace. I'll be creating. Why? Because I have dimensions. So I'll be rename this as a quarter wave. If you want, you can change your colors. Just click OK. Next, coming to a dimensions, I'll need to click this create rectangle. Then I'll be changing the dimension. The position is 23 mm, minus 0.25, 0.25, comma 0. Next, x size is minus 9 mm and y size is 0.5. Let's apply. Click OK. Now this line will be created. This is a quarter wave transmission line. I'll be created. After this, I need to create one more feed line. Okay. Now I need to create one more feed line using this rectangle. I'll be select this rectangle. I'll draw somewhere on the workspace. Then I'll be rename this as a feed line. Be create this as a field line. If you want to change the color, if you can change your colors, otherwise let it be. Next, create this rectangle. Then you can add your dimensions. The positions are minus 25, sorry, plus 25, comma minus 1, comma 0. And x size is minus 2, y size is 2. Apply. Okay. Now, able to see this? The field line will be created. After this, I need to do this unite. Okay, I need to do this as a unite. So I'll be selecting this patch. First, I'll be selecting the patch. I need to make this entire as like 3 different components as a single object. So I'll be make this 3 objects as a unit, like make a single object. So I'll be select this patch, water wave, and field line. Then I'll be select this unite option. Let's click on this unite. Now the like all 3 different components as looks like a single object. There is no gap here. It will be a single object now. Okay. Now I need to create a port here. Need to create port. So this is a different grid and this is a different grid. So I'll need to change the grid. I'll be change the grid. Able in a modeler, able to see this option called grid here. There I'll be select this drawing plane. Then I'll be changed to YZ or ZY. Okay, able to see the difference here. The entire grid will be changed. So I'll be take rectangle again. I draw a rectangle. For a rough dimensions, I'll be draw somewhere on the workspace, but I need to rename this as a port. Rename this as a port. Click OK. Then if you want, if you have a dimensions, you can draw this. Otherwise, you can draw a rough. Okay. Rough structure. I have a dimensions. The dimensions are minus 25, minus 1, minus 1.6. And y size is 2 and z size is minus 1.6. The position is minus 1.6. Okay, the position is correct. 0 is correct. Okay, now the port will be created. Now I need to assign lumped port for this port. So I'll be select this port option. Then the port will be the port triangle, the rectangle is highlighted. So I select this, right click on the workspace, and you can see this assign excitation. Just click on this assign excitation. Next port, lumped port. Okay, now the full impedance is 50 ohm. If you want, you can change the impedance there, port impedance. Then next coming to integration line, I'll be select new line. I'll be selecting a new line. Then I'll be draw from where you can see the triangle structure. It will be indicating it is a center of your bottom port. Like for your rectangle, that is a center. From the bottom, this is the center. Once you see this triangles indication, drag it up. Then again you see able to see this triangle. This is indicates again center. You can assign like wherever you want. Like it should be a direction. The current direction is like bottom to top. Then it's defined. Click on next. If you want to change in like all modes, if you want to change the modes, just you can enable this. Otherwise, you can go with like normalize the thing. Click finish. Now the port, like for the port, will be assigned. Go to the project manager. Just click on this excitation. Now click on this one. Now the excitation will be created.
Uh, Excuse me, sir.
Yes.
Sir, where do we use lumped ports and where do we use wave ports, sir?
Sir, if you want to design any filter kind of structures, that time you can go with a wave port. If you want to do a normal designs like antenna structures or arrays, that time you can go with this lump port itself. So based on your project requirement, what you want to achieve, for example, you want to give a more as like as parameters, or like if you want to more in the sense of large structure, you go with a wave port. It depends on your like structure. Sir.
So can you explain with some examples, sir? I couldn't understand, sir.
For example, where you can use waveport means you can when you are creating a bandpass filters or RCS designs, like if you are designing any radar cross sections or radomes or for stealth applications, but that time you can go with the waveports. Okay, if you are creating a normal antennas like microstrip patch antenna, or Yagi or BLD antennas or boat antennas, that time you can go with the lumper port. If you want to do a unit cell concept or phased arrays, that time you can go with a fluket port. If you are basically if you are doing any metamaterial structures, that time you can go with the fluket port.
Okay, sir. Okay, sir.
Yeah.
So another doubt is again it depends upon the type of model, no, sir. Whether it is a
Yes,
model
it
or
will be a
network model.
model or terminal. It depends on
For
that also. It
where
will
to
be
choose
just
that too,
changed
sir?
to coming to terminal. There is no current directions.
Okay, sir. No current direction in the sense here there is
Like
a current
we
direction, no, sir.
draw a line, right? This line.
Yes, sir.
This is the directions. In that we didn't assign the directions.
Okay, so we can also do the model analysis in the normal patch.
Yes, yes, yes,
We
yes,
don't want to know about the current direction.
yes.
Okay, so in that case, can we use a wave port or lumped port, sir, with a
Which in which
microstrip patch?
in microstrip you can use a waveport. Like it will be you will be doing an array means that time you can use a waveport also.
Okay, only if we
Large
want to
array
know the current
structures.
direction, then we can go for
Yes,
terminal.
yes, yes. Why? Because why we are using this microstrip means to check like return losses and all. For that purpose, we want to check the electrical distributions inside a structure. For that purpose, I'll be giving the current directions here. Like if you want to do a T and TM mode, that time you can use this line current directions. If you want only a TEM mode for entire structures, you can go with normal terminal options there.
Okay, the for coaxial cables, right, sir? For that one,
So that coaxial cable also you can use lumped port.
lumped port.
Yes.
Okay, sir. Thank you, sir.
Thank you. After assigning this excitation, now I need to assign a boundary conditions. So I'll be select this patch and ground. Select patch. Right click on the workspace. Assign boundary. Perfect E. Next click. Okay. Now the perfect E will be assigned. Perfect electrical conductor will be assigned for this patch structure. Now I need to assign for a ground also. So I'll be selecting assign boundary. Perfect. After assigning this boundary conditions, now I need to assign frequency, operating frequency. I need to assign. So after this, I just click on this analysis, add solution setup, advanced. Here I'll be assigning my operating frequencies. Okay. In this frequency, I'll be click on 2.4. This is my operating frequency for this microstrip patch antenna. Based on number of iterations, it will be give more accurate results. Or based on this, you get a proper results. So I'll be changing number of passes. Number of passes I'll be make it 20. It will take some time based on number of passes. Also, the simulation time also be increased. It's a number of iteration, like how many iteration you want to do for this structure to get an accurate results. Based on your requirement, you can give this number of passes there. Then I'll be click OK.
Sir, here also I have some doubts, sir. Where
Sir,
do we use the multi-frequencies and broadband, sir?
you are doing
Because
any
in
dual
types
band
in
application?
case of reconfiguration and all, we use for
That time,
multi-frequencies.
yes, that time you can use a multi-frequency. If you are doing any dual band application, that time you can use this multi-frequency and the broadband options.
For broadband, sir, if we are go with the continuous frequencies like wideband.
That for that type of applications, you can go with the broadband application for Wi-Fi applications or Bluetooth applications. That time you can go with that broadband. And if you want to do like multi-frequencies for reconfigurable, if you want to assign a multi-frequencies, like how your structure will be behave for a multi-frequencies. For example, I need to check the results for a 2.4 gigahertz and 3.6 or 5.2. That time you can use go with a multi-frequency options.
Okay, sir.
Yeah. Next, this is sweep. There you can see the sweep types. We have discrete and interpolating and the fast sweeps. We have only three types of sweeps we have. Coming to discrete, where you can use discrete frequency sweep means if you want to solve using the adaptive mesh at every frequencies, for that type you can use a discrete sweeps. The field is will be generate at all points what are the specified frequency in the sweeps. For that type, you can go with a discrete sweeps. When you are using fast, those fast sweeps generate all full field solution with a specified frequency range. Next, when you are using interpolating, the interpolating sweeps generate a solutions for S matrix over defined frequency range. What we defined a frequency range, for that frequency range only S parametric like S matrix results, or it will be generated using this sweep conditions. Okay, I'll be using interpolating sweep conditions. Then I'll start frequency from 1 and stop at 3. Click OK. Now I'll be assigning frequencies. Now I need to create a radiation box. Now I need to create a radiation box. Now I'll be right click on the workspace. I'll be creating automated radiation box. I'll be right click on the workspace and create open region based on my operating frequency. It will be created using the lambda by 4 values. So right click on the workspace, then I'll be mention the operating frequency. The boundary condition will be a radiations. Then I'll click OK. Now the entire radiation box will be created. If you want to change the values of the radiation box, just you can go to the history tree, click on the vacuum and change in the radiating surface. Then you create regions, then you can change the values. And we change it to 20. If you want automated way, you can create it using using a box. Then you can create a structures. For example, I'll be showcasing here itself. Then I'll be select this box and I'll be create a box and I'll be assign the frequency for that. Sorry, dimensions for that. Then you can make this as a radiation boundary using assigning boundary options. As of now, for this design, I'll be showcasing only in an automatic, like in auto open region boundary conditions. It automatically creates like entire box based on your operating frequency. It will only calculate the patch length and patch width for your design.
Excuse me, sir. Small doubt, sir.
Yes,
So
of course.
here there's the option, no, sir. PML. So where to use the PML and where to use the open region, sir? Can we use open region for all kind of projects, sir?
This is the open region, sir. Auto open region means if you don't need to draw an boundary like outer boundary, that time you can go with this automated boundary conditions. That PML is like periodicity boundary, like it's a perfect matching layer. When you are doing any complex designs and hybrid solutions, like hybrid solvers you are using, that time you can go with perfect matching layers.
Okay, sir. Can we go for arrays means can we go with the PML?
Arrays, it's very large means go with the PML.
Okay, sir. We have to define the structure, right, sir?
Yes, you need to define structures based
Lambda
on
by
it.
4, sir.
Like
What is
if
the
you
size?
based on your requirement. For example, if you want to do like numerical simulations to absorbing boundaries, or if you want to calculate outgoing waves or like open boundaries or minimal reflections, for that part you can go with this perfect matching layers.
Sir, can you repeat again, sir? Sorry, sir.
If you are doing a numerical simulation to absorb the outgoing waves, for example, if you want to do a numerical calculations for like outgoing waves, that time you can use this perfect matching layers, or for modeling a open boundary with minimal reflections. For that
Okay.
purpose, you can use this perfect matching layers. It's based on your requirement. You can assign lambda values.
Okay. So for S
It's
parameters in
completely for
general, we go with open digit.
thickness. It will be based on a thickness thing. It's like thicker PML generally provide for better absorption. If you want to do like absorption uh, designs, that time you can go with this PML boundary conditions.
Okay. Then for normal applications, we can go with open digit for any
Non
kind of design.
radiation.
Okay, sir. Okay.
For normal region, you go with the radiation thing.
Okay, sir. Thank you, sir.
Thank you. Now, entire structure will be created. I'll be go with a validation check. Just I click on this HFSS validation check. There is no error. Like the design setting also correct, and 3D mode also correct, and the boundary condition excitations also correct. Mesh operations also correct. Like no need to mesh, it automatically mesh inside a structure, inside this HFSS tool. And optometrics, no, I didn't do any optometrics. Then I'll assign a radiations. Then click on close. Everything will be correct. Next, I'll be go for analyze one. Now I need to uh, save as a file name like microstrip patch. MPLJ selected. Save. Now the process will be going on. The simulation process is going on. It will take some time to solve this entire design. It will take 2 to 3 minutes to solve. And based on your system configuration, also you have very high end systems. That time you can go with like it will solve faster based on your system configuration. It will be entire like entire thing will be depends. Sorry, I get some error. Give me a minute. I'll maybe solve it. I think my legends thing is a problem. If you have any doubts, please let me know.
Sir, a small doubt, sir. Sir, in your session, ma'am said that while going with any kind of design, don't just go blindly. Go with the reason for choosing the type of a material, and go with the electrical length for choosing any kind of design.
Electrical length.
Yes, sir.
Okay.
First, start with electrical length. So, how to proceed with that, sir? For
Sir,
any
for
kind of, for
example,
example, GPS frequencies or 2.4 gigahertz frequencies like that. So, how to consider and how to start proceed with the design, sir? Like how to consider the electrical length and how to start proceeding, and how to
sir,
choose the
first you need
material based
to
on that.
calculate the operating frequency for what operating frequency you are calculating. Then you can go with our normal calculations there, like theoretical calculations. Then once you will able to get a perfect what patch and width, then you can go for like online. We have so many calculators. Just you can type microstrip patch calculator, EM calculator, or EM type calculator. There you can calculate your patch length and width. Based on that, you can go with your designs. It's like completely depends on user for what applications you are doing and what frequency you are doing. You need to do a background work for those things.
Okay, sir, but for different parameters, we have to choose a different dimension, no, sir. Like if you want to increase bandwidth, or if you want to change the impedance like that.
That's what,
If
sir.
you
That's
want to
what I'm
improve
telling.
the return loss, which parameters should be that, sir? Like length or width or like that, sir?
I didn't get, sir. Can you repeat your question, please? Sir, can you repeat your question, sir?
I
Hello,
have one
sir.
doubt.
Yes. Tell me, sir. Tell me.
Sir, there is a
For
different
example,
parameters, no, sir, like return loss, bandwidth, like that.
Sir,
So if
that
you
all,
want to make some adjustment, which parameters should be approached, sir?
sir,
That's
you need to play with patch length and width itself.
for all kind of parameters. We have to go with the length and width.
Yes, length and width of the patch.
sir,
For
one more
return
doubt,
loss
sir.
and bandwidth, sir, what is the difference, sir, for return loss and bandwidth? If you want to make changes in return loss or if you want to change in bandwidth, which parameter should be approached, sir? Length
You
or
want to
width?
change in like S parameter, then you can go with the patch length.
Okay, sir. For bandwidth improvement, sir.
Bandwidth also you can go with the length and width based on like I need to check your project, like what you are doing with and where you are concentrating with. All those things I need to check. Then only I can suggest like where and which setting you need to do.
Okay. So there is no proper procedure. We have to check both the length and width.
Yes.
Okay, sir. Okay. Okay.
So one more doubt, sir.
Tell me, sir.
So for example, if I design a patch and by using EM calculator, for example, for 2.4, I have got the patch dimensions are 25 into 25, sir.
Hmm. Yes,
So
sir.
how to
Yes.
estimate the size of substrate and the ground, sir? Is there any
Sir,
relation?
I'll be suggesting one book for you, sir. There we have entire formulas to calculate substrate and like quarter wave dimensions. Everything there using like formulas only. Then you can calculate the substrate of
Okay,
the patch.
okay,
Then you can do some trial and error methods. Uh,
okay,
all those things you need to play with tool itself, sir. You can
okay,
refer microwave antenna theory by A. Balanas. There you can refer chapter number 14. There you can see microstrip patch. There you can see the formulas. Uh, there itself, sir. There we have some formulas.
we are finding formulas for length and width, sir,
Yes,
of patch. But
yes, and we have some effective
I am
formulas
asking
for
for
yes
ground
substrate
and
also.
substrate.
Substrates also
Substrate.
there, sir. There we have some formulas
Okay,
there based
right.
on your patch length. It should be doubled. Like for example, you are using 25 mm of length of a patch. It should be doubled, like 50 mm.
Okay,
Substrate length is doubled.
okay, right,
50
right.
mm. It should be in a 50 mm. You can refer that like microwave antenna theory and design textbooks. There we have some formulas there
Okay, sir,
for
right, sir.
calculating the like number chapter number 14. You can refer it.
Thank
Sir,
you,
but that formulas are applicable only for the basic design, no, sir.
It's a basic design. Then we have some. There will be continued parts. Just I'll be studying the basics. Means I'll be referring the chapter number 14. There you go with chapter number 14. We have some complicated designs where you need to do antenna arrays. And those things need to cover with the theory itself.
Okay, sir.
Yeah. Give me a minute. I think it will take some time to analyze. Able to see my screen, right? It will be analyzing. This is a progress. It will be analyzing. It will take 2 to 3 minutes. It depends on the system. So it's like security purposes there. So it will asking password. Yeah, now the simulation is completed. First, I'll be showcasing as parameter results where we need to get a results. Just click on this results in a project manager. Otherwise, you can go with HFSS. There we have a result part. There also you can click it. Just results, create model solution data report. Then go for rectangular plot. Then select as parameter quantity S11. Then go with the function dB decibels. Then click new report. Able to see this result. This is entire S parameter results. This is like operating frequency where the results will be there, and how many dip will be there. That also you need to analysis using, like, once you will be more comfortable with theory, then you can analyze it easily, very easily. Next, if you want to check the radiation pattern, before going to the radiation pattern, first I need to add this radiation pattern 3D. Just click on this, and the pie start from 3D for field radiation fields is available in this project manager itself. Just expand it, then click on 3D. Then you need to enter the pi start value and stop value, and theta start value and stop value. Just click on OK. Now I'll go to the results, right click on the results, create for field report, and just click on 3D polar plot. Then go with the gain total. Function is decibels. Click new. The entire structure is a 3D gain plot. If you want to visualize 2D gain plot, just click on this create for field report. Click on radiation pattern, gain, go with gain total, function is decibel. Then I'll need to select only 0 degree and 90 degree value. So I'll click on this families. I just click on this pi value all, then I'll be selecting 0 degree and 90 degree. Zero degree. Using control command, I need to select this 2 degrees. Then click new report. Able to see this green and red color. This red color indicates H plane and green color indicates E plane. Okay, this is a gain plot. Then I need to do some like electric field distributions. Then I need to hide this radiation box. Just hide it. Select a patch. Select patch. Right click. Plot fields. E field. Select magnetic E. Plot fields. E field. Magnetic E. Then no need to select anything. Just go with done. It will be taking some time to solve it. And look at the top view. Then if you want to animate, just click on, go to this field overlays, click on this plus, click this expand option, E field expand, select mag E1, right click, click on this animate. You're able to animate the structures, and you can see how it will be distributed, like entire structure. I'll be faster. Like this will be a field distribution inside a structure. If you want to see the entire thing, you select all object, and you can see like all object how it will be electric field will be distributed. Then if you want to visualize E field, showcasing like J vectors, select this vector E. I need to select the geometry first. Plot fields E vector. Click OK. It will be show a results in a vector form. Just click on this vector, animate. Click on that. Now it will be animate. How the vector will be, in this results will like electric field distributed in a vector form. This is a way. Okay, if you have any doubts, please let me know. I think it's like I have left only five more minutes to go with the metamaterial. So I'll be do that metamaterial design tomorrow. I'll just showcase the metamaterial designs and the results, what are the results we're expecting, and I'll be cover all those bandpass filter. And tomorrow I'm planning to showcase a specific absorption rate. For today's session, I'll be how to import a human phantom. Just I'll be showcasing that. In the next session, I'll be showcasing how to make an array. Otherwise, I'll be showcase how to make an single arrays using this antenna structure itself. Okay. In 5 more minutes, I'll be showcasing how to create an array for this. Now, select all. Select all. This is like how to create an array. We have options to create array here, but this is like manual way to create array, like 4 into 4 arrays or 8 into arrays. That is a simple steps I'll be showing. Just you will be create a large structure, means you go with like enable this solution, and you can enable this option for a large structure, then you can go with the creations. For this design, I'll be going with normal manual thing. So I'll be select all, right click on the workspace, edit, duplicate, move along the line. Just I'll be click on this when it will be like corner. Once you're able to see the square there, this is indicates corner, and I'll be drag and drop like this. Now the total number of object is only 2, so it will be created. Okay, now I need to make this structure as a single structure. I need to unite the substrate and the substrate one to make a single structure. Next, I need to unite this ground and ground one to make a single ground. Next, I need to unite patch and patch one to make a single patch. So I'll be unite both. Next, I'll be select. Before going to that, I need to create a coordinate system here. For that, just go with a modeler option. Modeler, coordinate system, create relative CS and offset to create a different coordinate system. Once you're able to see this triangle, this indicates a center of your structure. Just go click on this. Next, I'll select all. Select all. I click on the workspace, edit, duplicate, click around axis. Then I'll need to click 180 degree. Then I'll go with X or Y. Just click OK. And cross check whether this is correct. No, this is not correct. So I need to select X itself. Edit, duplicate, align, Z axis. Sorry, where we make a mistake means while be creating that coordinate system will be wrong. So it will give this error. I will be deleting this coordinate system. We'll be creating again. I need to create bottom of the structures. So go to the modeler again, coordinate system, create relative CS offset. Then I need to create here in the bottom. Here. Now I need to make the stop wave. Bottom anything is okay. Next, select all, right click, edit, duplicate, round axis. Next, you can rotate the structure for a better visualization. Now the Z axis is correct. Just click OK. Now the structure will be created. So again, I need to make unite to make a single structure. Unite the structure and unite ground 1 and ground 2. Just unite it. Next, unite patch. Now the patch also united. Okay, that all boundary conditions will be assigned here. Now, if you go for analysis all, I'll be do this 4 into 4 array for 2.4 gigahertz itself, gigahertz itself. Next, go for like everything will be created in Microsoft patch only. Just I'll be showing how to create an array. There is no error in this Microsoft patch antenna array. This is a 4 into 4 arrays. Go to analyze all. It will take some time. So for today, we'll be stop here. Then I'll be showcase the results tomorrow for this. And like you want to give a power for and single antennas, like only for this single antennas, that option also available. Only for this or this or this. You can give a power only for a single antennas to check how it will be behave in an entire like active or passive elements, how it will be behave in an antenna like array structures. All those things you can visualize like assigning the current, whether you can on and off this and like patches. I'll be showing this in a tomorrow's sessions. If you have any doubts, I have two to 3 more minutes. You can ask me. Then we'll be wind up the session. Then we can discuss the same on tomorrow's sessions.
Sir, I have a small doubt.
Yes, madam. Yes, madam.
Sir,
Yes, madam.
for all the 4 patches, the port is given separately or same port is
Separate, madam. All we need to give from 4 ports.
Okay. So what is the difference between array and MIMO antenna?
Normal a single patch. Why we are using array means we need to improvise the gain or improvise the gain of an structure. For that purpose, we will be using this array structures, like phase array or array thing.
Thank you, sir.
Any other doubts? Otherwise, shall we wind up the session? We'll be continuing from tomorrow's as per the schedule.
Participants, if you have any doubts, clarifications, you can ask.
Sir, hello.
Yes, sir. Yes, sir. Tell me.
Sir, tomorrow, first basic part you complete quickly, sir. Remaining
Sir.
part please provide more time for as new parameters while you are dealing with new parameters. So you please provide more time for new parameters.
New parameter in the sense, sir, metamaterials, those kind of
Yeah.
structures.
Yes, sir.
I'll not, sir. Just in a click wise, I'll be creating all those
Okay,
things. So for
right.
like why I'm taking this much time means to understand like for new participants.
Yeah.
Tomorrow I'll be very rush because tomorrow
Okay,
is the
sir.
last day.
Right.
Tomorrow is my last day session, so I'll be in very hurry. So I need to cover the band pass. I need to cover with the SAR rating. Then I need to do a
Okay.
metamaterial. So
Okay.
like you need to record the session, or if you want to take a snapshot, if you want to take a photo of that, you can take it.
Okay, sir. Right.
Okay, thank you, sir. Thank you. There is no doubt means, shall we wind up the session?
A wonderful session, sir, today. We have a
Thank
wonderful
you.
session, hands-on session.
Thank you, sir. Thank you. Thank you for your feedback, sir.
Thank you, sir. Thank you, sir, for spending your valuable time.
Thank you, madam. Thank you.
Thank you. Thank you, participants, for your active participation. We will share the video recordings. So once the FPP it's over, we will share the video recordings for all the participants.
Okay. Thank you. Thank you for participating. Thank you. Thank you.
Thank you.
Thank you.
Thank you, sir.